Hi class, this is lesson 12.4, volume of prisms and cylinders. So the volume is a little different than what we're talking about here. The volume of a solid is the number of cubic units contained in its interior. So we were doing area, and that was how many squares of a certain size would fit. Now we're talking about how many cubes of a certain size would fit. So our first volume postulate is the volume of a cube postulate. So the volume of a cube is just my side length cubed to the third power. Postulate 28, the volume congruence postulate, says if two polyhedra are congruent, then they have the same volume, which makes sense. Postulate 29, the volume addition postulate, tells us the volume of a solid is the sum of the volumes of all its non-overlapping parts. So this is where we can take a shape, kind of odd, different shape, and split it up into pieces and find the volume of each separate piece. Theorem 12.6 is the volume of a prism theorem. So the volume V of a prism, this is an important one, V equals capital B, so my base area, times my height. Theorem 12.7, the volume of a cylinder, well, it's still the same thing. It's still the base area times the height. But sometimes for a cylinder, remember, the base area is pi r squared. That's how we find the area of a circle. And then we multiply that by the height. So you don't have to remember that. You don't have to memorize it. If you just keep in mind base area times the height, you'll be fine for a cylinder. So example 1 here says find the volume of the solid. So my base is right here. So I'm going to do volume equals base area times height. My height right here is 2, so I'm going to put a 2 in there, but I need to find my base area. Since this is a triangle, it's 1/2 my base times my height. So it's 1/2 my base is 3, and that 1 foot is at a right angle to the 3, so we know that's my height. Half times 3 times 1 is 1.5. So my volume equals 1.5 times 2. 1.5 times 2 is 3, and for volume we use cubic feet. B is the volume of a right cylinder. So again, we're still going to use volume equals base area times height. But to find our base area here, since our base is a circle, we're going to use pi times our radius squared. Since our radius is 5, it's pi times 5 squared. So my volume equals, my base area is 25 pi times my height is 6. So if I just do 25 times 6, that would give me an exact value of 150 pi, and my unit would be cubic meters. Or if you wanted to round that, which we can do that as well, it would be 471 and 24/100ths cubic meters. All right, let's look at the next page. So you should pause it and try these two on your own. Remember, for both, you're still using volume equals base area times the height. So pause it and try these two on your own. Okay, so for this one, really, you could pick a few different sides as your base. I'm going to pick this side right here as my base. So my base area, since it's just a rectangle, it's going to be 4 times 5. So my base area is 20. So volume equals my base area, which is 20, times my height of 11. So volume equals 20 times 11, which would be 220, and my units would be meters cubed. The next one, we have a circle. So again, my base is a circle. I don't have a circle, I have a cylinder. So the base area is pi times our radius squared. So it's pi times 6 squared. Well, 6 squared is 36. So my volume equals 36 pi times my height, which is 9. So if you do 36 times 9, that's 324 pi. And my units would be feet to the third power. Now that would be my exact value. If you wanted to round this, do 324 times pi, you would get 1,017 and 88/100ths feet cubed. And that would be my rounded value. This next one says, think about how many unit cubes would fit into the figure. So really, that's what volume is. Volume is how many units, how many cubes of a specific size fit into a shape. So I'm actually going to split this up into two. If you can imagine splitting this up into two here, we really have two cubes here. So we've got one in the front and one in the back. I like that so you can see it a little bit better. Okay, so we've got two cubes here. So let's first find the volume of this cube right here. So I know this is 4. This side right here, this side is going to be the same as this side over here. And this one's 4, so we know this side is 4 as well. So for this larger one, my volume equals my base area times my height. Well, my base area, 4 times 4, it's going to be 16. So my volume is 16 times 5. So 16 times 5 is going to be 80. Now looking at this one right here, I need to do my volume equals my base area times my height again. So looking at the top, oops, I moved it over. Looking at the top, I'm going to look at this top right up here, make that my base. So this right here is 4 and the back side is 5, and with that being a rectangle, it'd be 5 times 4, which is 20 as my base area. So the volume for that piece is 20 times my height, which is 2. 20 times 2 is 40. So I've got my two pieces, so I now need to add them together. I have 80 cubic units, plus I have another 40 cubic units, so my total is 120 cubic units. And notice I just split it up into two pieces, found the volume of each piece, and then combined them together. All right. Not sure why that red arrow is still on there. Okay, so it says use the volume of a prism or cylinder for the next problem here. So it says the volume of the right cylinder is 1,253 cubic centimeters. Find x. So if you look here, x is our radius. So we're looking for our radius. So volume equals the base area times the height. Our volume, we're told, is 1,253. Our base area, since that's a circle, my base area is going to be pi times my radius squared. So we're going to plug pi times our radius squared in for b, and then my height is 10. So I set up my problem. Now I need to solve for the r. So I'm going to divide both sides by 10 pi, because that'll cancel out that 10 pi. So the pi's cancel, the 10's cancel. So I have r squared equals 1,253 divided by 10 pi, and I'm going to keep it just like that because I'm very concerned about having exact values. Then I'm going to take the square root of both sides. So r equals, now you can put this in your calculator. And when you put it in your calculator, do the square root sign, and then do 1,253 divided by, open a parenthesis here, and do 10 times pi, and then close your parenthesis, and you'll probably have to close it again for the second time. And then if you do that correctly, your answer that you should get will be about 6 32 centimeters cubed. Not centimeters cubed, I find my radius, so just plain centimeters. So pause it and try the next one on your own. Okay, so for this problem, again, we're talking about volume. We're trying to find our diameter now. So we know that our radius is going to be half of our diameter. So we can say volume equals base area times height. The volume is 200 pi. It tells us that in the problem. My base area is pi times my radius squared, and my radius is 1/2 x squared. And then we still need to multiply that by our height, which is 8. So to solve this, I'm going to divide both sides first by my 8 pi to get rid of that. So the pi's will cancel and the 8's will cancel out there. My pi's right here will cancel. 200 divided by 8 is going to be 25. And that equals, now we have 1/2 times x, the quantity squared. Next we need to get rid of that squared side, so we'll take the square root of both sides. Square root of 25 is really positive or negative 5, but I'm just going to use my positive 5 since I'm talking about a side length. And that equals 1/2 times x. Now remember, to undo a fraction, we're multiplying by the reciprocal, so I'm going to multiply both sides by 2. 2 times 5 is 10 equals, and the other side I have x. So my answer is right here. That is 10 centimeters. All right, let's turn your notes over and look at the next side. So it says find the volume of an oblique cylinder. So we know, because this oblique cylinder has the same area as one with a base of pi times 5 squared, or 25 pi. And it's got this height right here, and that height is at a right angle. We can still use volume equals base area times our height. So we can say volume equals, my base is 25 pi because it's still pi times my radius squared, and since my height is at a right angle, my height is 8 there. So volume equals 25 times 8 is 200 pi, and my units would be inches cubed, and that would be my exact value. If you round it, you would find that that's approximately 628 and 32, and that would be inches cubed. We're going to skip this next one because it involves using a little bit of trig, and we're not going to do that today. So let's look at the last part here. It says find the area of composite solids. So a composite solid is when you put more than one together. So example 4, find the area of the solid after a solid tube has been carved out of the middle. So what we want to find here is we want to find our big cylinder, and we're going to subtract from that our small cylinder. Okay, so that's what we're going to have to do. We've got a large cylinder, we're taking out the small cylinder. So for our large cylinder, our volume equals our base area times our height still. And for our large cylinder, my base area, well, this is my, right here, that's my radius of my large cylinder. So my base area is going to be pi times 3 squared. 3 squared is 9 pi. For this big one, b equals pi times 3 squared, or 9 pi. That's my base of my large cylinder, times my height of my large cylinder is 7. So my volume equals 63 pi for my large cylinder. Now for my small cylinder, looking right here, this is my radius for my small cylinder. So for my small cylinder, my base area is pi times 1 squared. Well, 1 squared is just 1 pi. So my small cylinder, volume still equals base area times height. So my volume equals, my base area is pi times my height is 7. Well, pi times 7 is just 7 pi. So I'm now going to subtract these two, 63 minus 7 pi, 63 pi minus 7 pi, and that'll give me 56 pi, and my units are millimeters cubed because we're talking about a volume. And if you want to round that, if you put 56 times pi into your calculator, you'll find that it's about 175 and 93 hundredths, and my units are millimeters cubed still. So there's my exact value and my answer rounded to the nearest hundredth. On your own 4, it'd be a good idea to pause this and try this one on your own. Okay, it says find the area of the composite solid. So on the bottom we've got a cube, because we know it's 4 here and 4 here and 4 here. So for that we know volume equals side length cubed. So volume equals 4 to the third power. 4 to the third power is 64. Now we also, up on the top here, have half a cylinder. So it's going to be half times our cylinder. So we're going to do half our base area times our height for our cylinder, because we only want half of that. So my base area for my cylinder, well, all the way across is 4, so my radius for my cylinder is going to be 2. So my radius for my cylinder is pi times 2 squared, so that's 4 pi. So I have half times my radius of my cylinder is, or my area of my base of my cylinder would be 4 pi, times my height of my cylinder is still 4. So half times 4 is 2. 2 times 4 is 8, so I have 8 pi as the area of my half cylinder. Now we're going to add these two together because they're combining. So I have 64 plus 8 pi, and you could keep it like that for your exact value, or if you want to round it, it's about equal to 89 and 1300ths, and that would be inches cubed. And this is the most likely answer that we would see for that problem. This is the end of the lesson. Make sure if you have any questions, you ask me about them, and have a great day.